This is the screen of the Shapeko router, the driver, and one of the problems with it, as you can see, is that when you go to run this program, I'll put it right here, you can see that there's no graphic of the piece that you intend to cut. So when you come over here to the router, you end up with this problem of not knowing really where extents of the cut are going to be on the table without actually asking the router to show you. So that's what I'm going to be doing here next. I'm going to use the router to trace out exactly where it's going to cut so that I can make sure that it cuts on the material the way that I want it to. What I've got here is some cardboard, which is a sacrificial material that I can cut to determine what the shape of the eventual cut is going to be without tearing up the G10 material that is expensive and you don't want to mess it up. So that's what we're going to do next. I've got it set vertically so it won't come all the way down to the material. It'll just show me about where it's going to go. So we know it's going to start about here, and then it misses right here. The corner is right about here, which is not good, but it's what we've got. And so this corner is right there. This is what people call an air cut. So that's the first piece right there. The second piece will end up down here. We'll see if it goes over the same. Yeah, you see it does. It nips off a corner. And it comes right down to about here. So the problem that I've got is that I need to see if I can, this right here is a model out of the scrap material of the actual material that I've got, the G10, which is 24 inches by 24 inches. That's what we're going to try and cut these two pieces of the flap out of. So this is one side of the flap, the left side, and then this is the right side. As you can see there, we go off the edges of the material for one of the corners, and that is not what we wanted. And I had the problem is that the flap itself is a little bit longer than the longest dimension, the longest orthogonal dimension of this piece of material. So we rotated it such that it would try and fit in along the hypotenuse. And on my CAD drawing, it did fit within the 24 inches. And now that as I cut it out on here, it does not fit. It goes beyond the edges a little bit. And I need to know why. And the best way to do that is to make sure that I don't have some sort of scale error here. And the way I'm going to determine that is to go ahead and turn the router on and let it cut this cardboard out now that I know approximately where it's going to go. And then I'll measure these pieces and compare them with the original drawing and see if I can't determine where the problem is. Okay, so I went back to the CAD system and I discovered that the problem was the fact that I hadn't defined the size of the stock in the right units. It's the old inches millimeters thing. So I corrected that, and I reoriented the two flaps a little bit, and computed the NC file, which we are going to try again right now and see how it works out. And we should get it on the edges of the material now. This is going to be another air cut, just to check and make sure. See, that's better. That corner is now inside the material. So she should come up right about to this corner right here, which it does. And it's still inside all the way. One corner. Next one should happen right about here. Look at that, it comes right out over the top of my screw. Okay, so it works good, but I got to move this screw to make sure I don't break the router bit on the screw. Which is another really good reason to make an air cut before you have committed yourself to it. Okay. Now what I have to do before I get ready to make this cut is to reset the Z-axis so that it gets the right depth. And I will do that, and then we will make the air cut. We'll make the actual cut in this cardboard. If we get the cut in the cardboard looking correct, then we'll go ahead and put that piece of G10 on here and cut it. Setting your Z on any kind of milling machine, which is what this is always a critical process. And the way that I do it, the way a lot of machinists do it, is they use a round object of some kind. This is a center drill here that I know, because I measured it, is exactly 6.31 millimeters, since we're working with metric here. So what I'm going to do is I'm going to set the bottom of the cutting face of the cutter here to just caress the top of this 6.31 millimeter object, and then when I define that to the machine, I'll just tell it that the bottom of the cutting surface here is 6.31 millimeters above the work, and that will effectively zero this right on the surface of this material here. It's a little awkward because I have to walk back and forth, but I know that I need to come down here about 6 millimeters or 7 millimeters. This is what I'm going to do. What we're doing here. Okay, so you can see that this is exactly 6.31 millimeters now above the surface of this work. I know this is irregular, and it doesn't really matter very much because I'm just cutting the cardboard. But it's important, especially that you don't go too deep with the cutter. The G10 is 1 millimeter thick, so that's all we're going to cut into this. It will not go all the way through this, but it will give me a good idea of exactly what these pieces are going to look like. So I'm now going to set the Z value at 6.31 millimeters, and then we'll turn the router on and go ahead and run this cut. Okay, these look about right. It's about what I expected. I'm using a 1/8 inch router bit with a 1/4 inch shank, an upcutting router bit. The idea being that it brings the chips upward because there's nothing below. And it's running about 27,000 RPM. These small router bits have to run real fast in order to achieve the surface rate that you need for this kind of work. So the next step of this process is going to be to replace this cardboard with the G10 and make the same cut in the G10. I'll have to make sure I get the fastening in the correct spots so that the holes that I have to make in the G10 will not fall over the top of important structural members, and I'll look on my CAD file in order to do that. And then we'll come back and we'll cut the G10. Okay, just in the interest now of making absolutely positively sure that I'm not going to have any interference with these screws, we're going to make one more air cut just to trace the path, and then if that works out, we're going to go ahead and cut this piece for real. Okay, the last, that looked fine, and the last thing that we have to worry about here is the feed rate. Okay, we'll begin for real this time. was pretty terrorizing, but it worked. This material is real thin, and you get a lot of bending between support points, more than I thought you would, and so that's why I ended up having to rescue it. We'll see how it works out here. They're pretty good. They require a little truing up along the edges because there's a little bit of blood mixed with them. But I'll touch these with a file, and that should take care of that. So then we're on to the next piece.